What specific problem does your benchmark aim to solve in the realm of evaluating role-playing language models, and why is this considered significant?
Our benchmark aims to solve the problem of evaluating role-playing language models in a more dynamic and realistic manner, addressing the limitations of existing benchmarks that primarily focus on single-turn interactions and often suffer from data contamination. This is significant because traditional evaluation methods do not accurately reflect real-world usage, where multi-turn conversations are common, and they can introduce biases due to reliance on a single model for judgment. By employing a multi-model evaluation system and allowing language models to emulate users in role-playing scenarios, our benchmark provides a more comprehensive assessment of conversational abilities. Additionally, the correlation with manual annotations validates the effectiveness of our approach, ensuring that the evaluations are reliable and reflective of human judgments. Overall, this advancement enhances the understanding of role-playing capabilities in language models, which is crucial for their application in entertainment and other domains.
Can you illustrate the step-by-step workings of your proposed multi-turn benchmark methodology, specifically detailing the roles of the player, interrogator, and judge models?
The proposed multi-turn benchmark methodology consists of three key roles: the player, interrogator, and judge. First, the player assumes a specific character role based on a character card, engaging in dialogue while maintaining character consistency. Next, the interrogator simulates user behavior by interacting with the player within a given context or situation, generating user utterances that prompt the player's responses. Finally, the judge evaluates the player's responses against predetermined criteria, which include character consistency, entertainment value, and language fluency. This evaluation process is structured to ensure that the judge provides a score for each turn of the conversation, allowing for a comprehensive assessment of the dialogue's quality. The methodology emphasizes the asymmetrical nature of role-playing interactions, where the interrogator does not have complete information about the character, reflecting real-world user engagement scenarios.
Could you provide an illustrative example that demonstrates how your proposed evaluation framework would function in a typical role-playing scenario?
In our proposed evaluation framework, a typical role-playing scenario would involve three distinct roles: the player, the interrogator, and the judge. For instance, if the player assumes the character of a wizard from a fantasy novel, they would respond to prompts based on their character card, which outlines the wizard's traits and background. The interrogator, simulating user behavior, might ask the wizard about their magical abilities or a recent adventure, engaging in a multi-turn dialogue. The judge, utilizing criteria such as character consistency, entertainment value, and language fluency, would evaluate the wizard's responses, scoring them on a 5-point Likert scale. This structured interaction allows for a comprehensive assessment of the language model's role-playing capabilities, ensuring that the evaluation reflects both the character's authenticity and the quality of the conversation.
What are the primary advantages of utilizing a multi-model evaluation system over traditional, single-model methods in your benchmark?
The primary advantages of utilizing a multi-model evaluation system in our benchmark include enhanced correlation with human annotations, mitigation of individual model biases, and improved evaluation accuracy. By averaging scores from different judge models, we achieve a higher correlation with manual evaluations, as evidenced by our results showing correlations exceeding 0.64 for both English and Russian. This approach addresses the self-evaluation bias inherent in single-model methods, which can skew results. Additionally, separating the roles of interrogator and judge allows for optimized costs and tailored decoding strategies, enhancing the realism of user emulation. Overall, the multi-model setup not only increases reliability, but also provides a more comprehensive assessment of role-playing language models.
Describe the experimental validation process you employed to ensure the robustness of your benchmark's evaluation criteria. What datasets and metrics were used?
To validate the robustness of our benchmark's evaluation criteria, We created 64 conversations for each of the 16 language models in Russian using the initial version of our setup. We then sampled 250 and 265 samples for English and Russian, respectively, and manually annotated them using a 5-point Likert scale. We computed the Spearman correlation between these manual annotations and the automatic annotations generated by different setups to assess the correlation's strength. The results indicated that correlations were higher than 0.3 for almost all attributes across versions, with the best model being Claude 3.5 Sonnet. This multi-model evaluation approach, which averaged scores from different judge models, demonstrated a correlation higher than 0.64 for both languages, confirming the effectiveness of our evaluation criteria.
In your results, you mention correlations between automatic evaluations and human annotations. Could you detail the specific outcomes and findings that support the effectiveness of your approach, including any limitations observed in language fluency evaluations?
In our results, we found that the Spearman correlation between different versions of automatic judges and human annotations was generally higher than 0.3 for almost all attributes across both languages, indicating a strong alignment between our automated evaluations and human assessments. Notably, after averaging scores from the two models, the correlation exceeded 0.64 for both English and Russian, surpassing the performance of any single model, which supports the effectiveness of our multi-model evaluation approach. However, we observed a limitation in the language fluency evaluations for English, where the correlation was lower due to the annotator not being a native speaker, making it challenging to detect subtle nuances. Additionally, most models performed well in fluency, which may have contributed to the lack of variance in this attribute. In contrast, the models struggled more with Russian, leading to stronger correlations in that language, highlighting the varying performance across different languages.